times 1, because those are what you'd be multiplying by. So you added into each of the exponents.
Yeah. Okay, so the first problem you had to do was 302. And when it was 302, what was the answer?
11, 11, 6.
Okay. What if it had just been 300? What would it be?
12.
9, 3, 12.
Don't look here.
Right? Because what is this then returning? Just the first column. How many times of the first column? 3 times the first column. So when this was 302, oh, sacrifice the carrot.
You have to eat it.
Wait, I'm not.
Oh my god, the mad one. You did it.
Wait,
Thank you.
focus, focus.
Oh,
Are we ready?
Thank
Are you
you,
ready?
we appreciate it.
You focus now? Alright. When we went to 302, we got 11, 11. Oh wait, what did we get?
Why did you have that?
Yeah.
11, 11, 6.
How? It's on the paper.
You did that one. But let's talk about it in terms of just the row, just the columns.
No, but that's what I'm saying, like.
So let's talk about it in terms of just the
we did it
columns.
the long way, but like.
Right.
Yeah.
Because what would have this given us?
The first column times 3.
Yes.
Okay. Oh.
What would that have given us?
The last column times 2.
The last column times 2. What would this give us?
First column times 3.
The first column times 3
Plus the last column.
plus the last column times 2.
Oh.
Oh, the system of equations.
Right?
Huh?
What?
Sorry.
Yes, it looks like the system of equations. So that's the whole point of me asking the question on the bottom.
Oh, because then the
Distributing
solution
thing.
transforms it into the identity.
So it'd be.
Okay?
So it'd be 9, 3, 12.
So this is going to be,
Yes.
the end result of this is going to be 3 times this
11.
plus 2 times
Oh,
this.
okay.
Oh, yes. Yeah.
Right? That's the fast way to think about this.
Oh, that's
What was the slow way?
Right?
Oh, wait.
us doing it is the slow way.
The slow way.
No, like us like going like this and stuff.
Yeah.
Oh, okay.
Yeah. Right? If you rearrange these calculations, watch. Okay? So let's do it the slow way.
How does it start?
Let's do it the slow way. Okay? What entry would go here if we did this the slow way? Tell me what calculation did you do? Don't tell me 11. Tell me what calculation we
9
did.
plus 0
3
plus
times
2.
3 times 3 plus
3 times 1 plus 2 times 4.
No.
5 times 0
Oh, yeah.
plus
That's like wrong.
1 times 2. Right? Okay. What went here? 1 times 3
Oh, but you can get rid of
plus
like half. of
3
it.
times 0 plus 4 times 2. That was how we got that 11. And then what number went here?
4 times 3.
4 times 3 plus
Negative 2
negative 2 times 0
Negative 6.
plus
Or negative 3 times
negative 3 times 2. Now when I look at this, what I notice is that I have 3, 0, 2 every single time, right? Which is what makes sense.
Yes.
Okay? So I could say this is 3 times 3, 1, 4 plus 0 times 5, 3, negative 2 plus 2 times 1, 4, negative 3. I'm just rearranging the dot product calculation. Instead of thinking about it as going across the row, I'm thinking about what would I end, eventually I end up taking 3 times 3 and 1 times 3 and 4 times 3, and those are going in 3 different spots.
What if it's 2 columns in the other one?
You do it twice.
Yes.
So can you just keep doing it?
So because if I did 3, 1, 4, 5, 3, negative 2, 1, 4, negative 3, multiply this by 3, 0, 2, 0, 1, 0, okay? in the first column of the answer, what's gonna go in the first column of the answer? That whole thing, right? 3 times this plus 2 times that. So I'm gonna think about this as columns. So the first column, the first thing is 3 times column 1 plus 2 times column 3. 3 of these plus 2 of these plus 0 of these that go away, right? And then what's gonna end up going over here?
5, 3, negative.
5, 3, negative 2. Why is it 5, 3, negative 2?
Because you do 1 times the second column.
Right. So if you end up with a bigger matrix, then they just end up next to each other, right? You can you just addend it along. Okay. This is really, really, really important, and I really, really, really didn't understand it when I took linear algebra in college. And that made the second half of the course incomprehensible to me, which was a problem.
Still is.
I'm out. I'm done after
So
this.
you can either multiply using the FOIL method, like this.
This is far, this is as far as you can bring us.
I'm done. I'm out. You're on your own front. Yes.
The
Or
FOIL method or the column one.
correct. And there's so many, and the column, thinking about matrix multiplication as a linear combination of the columns is faster and helps us understand why a lot of things make sense and work out. Okay? So when you read the textbook, when
If.
you read the textbook this weekend, your response is, of course we will, Obriki.
Do we have to say it in unison like we're drums?
Yes.
Of course we will.
Of course we will. Okay, this is called pick apart in the textbook. Or if you're Al, pick a pot.
What does that stand for?
So
Okay?
those are just the column multipliers. basically?
Column these, when we think about matrix multiplication, the matrix that we're multiplying by on the left, remember matrix multiplication on the right. Remember matrix multiplication is not commutative. That the matrix on the right tells you the weights for the column vectors of the matrix on the left. So, right-hand matrix gives weights for linear combination of left column vectors. Okay. This makes a lot of things make a lot more sense.
Like system.
What if
Like
it asks
systems.
you to figure out the second one to solve?
What do you mean?
Like it gives you the first matrix, and this is x equals third matrix. Because what we did was REF, is that correct?
That's fine, yes. You can REF it, yes. Yes, this is related to some things about inverse that we're going to talk about. Okay. Now, everybody okay with this? Okay, because now the really fun part is that we can also think about this. This is the way we're generally going to think about this. Most of the time when we want to think about this as linear combinations, we think about these as the weights, linear combinations of the columns, okay? We can actually also think about it the other way, but I always get confused. That these, wait, how does this work? Oh, I should have thought about this more while I was studying math. The rows of this matrix tell you the weights. Yeah, it's gross.
If you don't get it, we don't need to.
Yeah,
it's fine.
It's right
We
there.
can figure it out. Yeah, it's right here.
That's all he's trying to say. He just doesn't know how to say it yet.
Yeah, nobody does.
Can you try and say it again?
So you organize this the opposite way, right? So instead of focusing on the 3s and the 3, 1, 4,
You look at the 4, -2, and
you look at the,
That's like the long way.
Like the way we've been doing.
Yeah, that's it's just like, he's trying to figure out how to explain what we've been doing along the way,
It's
It
the same
works.
number of operations. you
but
do.
it's just not working.
Are you just talking about like
Are you just talking about
rotating?
dotting them
Yeah,
again?
dotting.
Yeah, it's easier to see when there's a, it's easier to
You just
see,
rotate the.
it's easier to see when this isn't,
Vertical.
Right.
only one
I'm not sure.
entry in the row.
I
Right.
think so.
So let's make up a bigger one. Wait, how much time do we have?
1 minute.
We're done in 1 minute.
Oh, never mind, okay, we'll deal with that next week.
Marty's like-
I'll think about this during conferences.
Marty's like-
It's easier to see if this doesn't have only one.
In the middle of a conversation.